here's an example where we have marbles, and there are 2 red marbles, 5 green, and 8 yellow in this jar. Martina randomly selects 2 marbles without replacing them. What is the probability that she selects 2 green marbles? So let's first figure out, is this set of events independent or dependent? So remember, when you have without replacement, you're not putting the marble back in, it affects the second marble probability. So these are considered dependent events. They depend on each other. Once you take one marble out and not replace it, the probability of that second marble being green affects that second event. So these are dependent events. So now let's go ahead and solve it. So we want to find the probability of getting 1 green. So our total of 2 and 4, 5 and 8, when we add those up, there is a total of 15 outcomes. So that will be our denominator. And we have 5 green ones. All right. Now, we're going to not put that green marble back, and we're going to grab that second green marble. So now, how many marbles do we have in the jar? Well, 1 marble has been taken out, so now we're down to 14. And how many green marbles do we have left? Well, we've taken 1 out, so now we're down to 4. So now we have a 4 out of 14 chance to get that second marble. All right. Now we want to say, what is the probability of getting the first green and the second green? We are going to multiply these 2 probabilities together, 5 15ths and 4 14ths. So 5 15ths is the probability of getting that first marble, then 4 out of 14 to get that second marble. We're going to go ahead and multiply across and reduce it, and we get a 2 out of 21 chance of getting 2 green marbles. All right, let's move on to this problem. A box contains 5 red and 3 blue marbles. Find the probability of getting 2 different colors. 2 different colors. So let's assume first that we replace the marble. So we grab a marble and then we put it back in. So probability of getting a red and then a blue, or probability of getting a blue then a red. So let's talk about the probability of a red. So we have 5 out of a total of 8. To get a blue, probability blue is 3 out of 8. Okay, so now let's go ahead and do these separately. So to get a red and then a blue, we're going to multiply these 2 numbers together. So 5/8 and 3/8, that's to get this one, plus blue then a red. Blue then a red. So 3/8 times 5/8. Let's see what we simplify this. So 5 times 3 is 15. 8 times 8 is 64. Plus 3 times 5 is 15. 8 times 8 is 64. We add those 2 fractions together. 30 out of 64, which reduces to 15/32. So replacement occurred. Now let's head down. The replacement did not occur. So you took the marble out, and now your probability has changed. So these are now considered dependent. So the probability of red, then a blue, or probability of a blue, then a red. All right. So I'm just going to write down again how many total we had. The probability of a red originally was 5 out of 8. The probability of the blue was 3 out of 8. care of this set of events. So red, then a blue. So we have the red, 5 eighths. Now we did not replace that red marble. So now this has changed to, instead of 8, we're now down to 7. So we have a 3 out of 7 chance to get that blue marble. All right, now let's head over to do the blue marble, then the red. So our blue marble is a 3 out of 8. And now we want to get the red. So we dropped one of the marbles off. So now we're out of a 5 out of 7 chance. All right, so now let's go ahead and multiply across. So 5 times 3 is 15. 8 times 7 is 56. Plus 3 times 5 is 15. 8 times 7 is 56. Add those numbers together. You have a 30 out of 56 chance, which reduces to 5/9. Again, the first one, A, is independent events because you replaced the marble. Part B are dependent events because you did not replace the marble. They affect each other.